भाई सब लोग ये कंफर्म करना कि ऑडियो क्लियर है, वीडियो क्लियर है और मैं हैंडसम हूं। ये तीन चीजें कंफर्म करना कि ऑडियो क्लियर है, वीडियो क्लियर है और मैं हैंडसम हूं। लाइव ऑडियंस नहीं दिख रहा है। अच्छा, पीडीएफ को चेंज करना है, चेंज कर लेता हूं। तुम लाइव ऑडियंस में जाना, ठीक है? ओके। माई नोट्स इज सफिशिएंट फॉर गेट, ठीक है? माई नोट्स इज सफिशिएंट फॉर गेट। माई नोट्स इज सफिशिएंट फॉर गेट। लोग बोलते हैं कि मेरा नोट्स बाइबल ऑफ टीओसी है, ठीक है? आप एक बार मेरा नोट्स देखने के बाद पीवाईक्यूज को सॉल्व करना, आपको ही पता चलेगा कि व्हाई दिस इज। आप एक बार तो भाई, today we are going to see a topic. I'm going to give you 4 tables. RBR table 1. एक minute. Import. Let me import. Import file. Downloads. 11 p.m. YT. TOC. Open. ठीक है, तो वी आर गोइंग टू सी टेबल्स आज। 4 tables वी आर गोइंग टू सी, ठीक है? एक्चुअली हम पढ़ रहे थे, एक्चुअली वी आर स्टडिंग टीओसी, रेगुलर लैंग्वेजेस। एक्चुअली वी आर स्टडिंग रेगुलर लैंग्वेजेस, ठीक है? And today I am going to teach you about 4 tables using which you will easily be able to. Today I am going to teach you. Today I am going to teach you 4 tables using which you can answer any question in 30 seconds and you will get 4 marks from that. Okay, 4 tables, just 4 tables. You have to remember 4 tables. Okay, yesterday we are doing regular languages. Today we are going to do tables. Okay, tables in TOC. So all these tables I created. I didn't invent them. Actually, I have collected the information, gathered together and put them in the tabular form. If you see these tables anywhere else, just remember that these tables came from me. If you need any proof, go to my 2012 videos, you will see all these tables there. Okay. So I didn't invent these tables, but I collected the information in such a way that you will be able to get at least 4 marks from these 4 tables. Okay. So let's begin with tables one by one. Okay. So before I start the topic, let me give some motivation. Okay. 𝐂𝐤𝐬𝐬, born in 1926 and died in 1984, he won India's first individual Olympic medal, a bronze in wrestling at 1952 Helsinki Games. With minimal training facilities, he defeated world-class opponents single-handedly. Jadav's pioneering achievement inspired Indians' future wrestlers, establishing him as the trailblazer in Indian sports history. What should you learn from this? You should learn that pioneering achievements accomplished against all odds can inspire national sporting excellence and perseverance. ठीक है? With minimal training equipment, he achieved a bronze for the first time for India. He is a great Indian and he is a hero to me and he should be a hero to you. Jai Hind. ठीक है? Let's start the topic now. So we are going to see the topic. ठीक है? So I am going to give you a table and we are going to discuss about that table. Okay? Closure properties. RBR table 1. Closure properties. Closure properties. Okay? Closure properties. Now, what are the closure properties we have? I will write down the table completely and then I will discuss the question. So let me complete the table first. Okay? So one more thing before going ahead, I want to talk to you about one more thing. If a languages are classified like this: regular, DCFL, CFL, regular, DCFL, CFL, CSL, recursive, recursively enumerable, and set of all languages. 2 power sigma star is set of all languages. ठीक है? Regular, DCFL, CFL, CSL, recursive enumerable, and 2 power sigma star. Right? So what you have to learn from this diagram is, if a language is regular, you can call it DCFL also. If a language is regular, it is qualified to be called as DCFL. If a language is DCFL, it is qualified to be called as CFL. Like that, you can call them, right? So if something is asked about regular, you don't know at that level, you can upgrade it to DCFL, you can upgrade it to CSL, you can upgrade to CSL. So I will show you, okay? I will show you how it is going to happen. Okay? I will show you how it is going to happen. Okay? So let's draw the table first. Okay? So RBR table 1. RBR table 1. Okay? So all the properties that we have is union, intersection. I will draw the table. Okay? Union, intersection, complement, star, concatenation. Dot is concatenation and reversal is L power R. L power R is reversal. And homomorphism is H of L. and inverse homomorphism is H inverse of L. Inverse homomorphism is H inverse of L. H inverse of L. Okay, okay. Now what are the various languages we have? We have regular languages and we have DCFLs and we have CFL, regular DCFL, CFL, CSL, recursive, recursively enumerable. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now I have collected the information from many textbooks and many sources and I have put them all together so that you can by heart them. You don't have to read the theorems. You don't have to prove lot of theorems and do lot of work. It can easily be done. Okay. It can easily be done. Right? Right? ठीक है. ठीक है. So in regular you are going to get all closed. In regular everything is closed. In regular everything is closed. In DCFL first two are not closed. Third one is closed. Complementation is closed. And next one is not closed. And next two are not closed. And next one is not closed. And next one is closed. In CFL first one is closed. Second one is not closed. Third one is not closed. Fourth one is closed. Fourth one is closed. And all of them are closed. In CFL, only two cross marks are there and all the remaining are ticks. And in CSL, first five are closed. In CSL, 1, 2, 3, 4, first five are closed. And in recursive, first five are closed. 1, 2, 3, 4, 5. 5 are closed. And in recursively enumerable, first two are closed. First two are closed. And next one is not closed. And then the next one is closed and closed. Okay. This part you ignore it. Okay. This part we don't have any theorems which are proving them. No one has proven these parts. No one knows about them. So there will be no questions here. So till now no one has proven this part. You will not find it in any textbook, right? Now this is called RBR table 1. You have to by heart this table. Once you by heart this table, you are going to get at least 1 mark from this. At least 1 mark from this always. At least 1 mark from this always. Okay, okay. So I'll tell you how the questions will be asked. I'll tell you about the table first, right? So whenever you see a tick, it means it is closed. Okay. What does this mean? I will take a different color. What does this mean? This means that if I take union of two regular languages, then the union is, if I take union of two regular languages, then the resulting language is regular. That is why it is called closed. If I take intersection of two regular languages, the resulting language is regular. What about cross? Cross means may or may not be. If I take union of two deterministic context-free languages, the resulting language may or may not be deterministic context-free language. If I take union of two deterministic context-free languages, the result may be deterministic context-free language or may not be deterministic context-free language. That is the meaning of it. Okay, 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 okay. So how the questions will be asked here? So they will say that L1 is regular. They will say that L1 is regular, and they will say that L2 is regular. L1 is regular and L2 is regular. When they say that L1 is regular and L2 is regular, then what is the resulting language? L1 union L2. what can you say about it? The table clearly says that when L1 is regular, L2 is regular, the resulting language is regular. You can say that the resulting language is regular. The resulting language is regular, right? Now, if they give you this question, L1 is context-free language and L2 is context-free language. What can you say about L1 union L2? What can you say about L1 union L2, right? So L1 is context free, L2 is context free, and they are asking about union of context free, right? Now we got union of context free, right? So what can we say about it? L1 union L2 is regular. L1 union L2 is regular. L1, sorry, context free. L1 union L2 is context free language. Now if they give you something like this, L1 is regular, L1 is regular and L2 is context free language. What can you say about it? What can you say about L1 union L2? I will give you third table. By using that table, you will be able to answer this question directly. But let's try to answer it with this table. Later, I will give you one more table using which you can easily answer this question. But from here, what can you say is, see, all these properties are applied to the same type of languages. They are not applied to regular and context free or context free, context sensitive. They are not applied. So what you have to do is you have to upgrade, right? So every regular language is DCFL and every DCFL is CFL. So what I can do is I can upgrade regular language to I can upgrade regular language to DCFL. I can upgrade regular language to CFL. Regular language to CFL, right? Now L1 is regular, L1 is regular and L2 is context free language, but I have upgraded L1 to context free. Therefore, L1 is context free language and L2 is context free language. So what do you get? Union of two context free languages. What do you get? What do you get? Union of two context free languages. Where is it? Union of two context-free languages. Union and context-free languages is closed. Therefore, the resulting language is context-free language, right? They will ask questions like this. That's it. Over. One table is over. You will get 1 mark from this. At least 1 or 2 marks from this. One table is over, right? So only things where you should be somewhat cautious is I will show you some questions which can be little bit tricky. So don't use the table directly. Use your brain first, then use the table. Okay. Use your intuition first. For example, if they say L1 is A plus B star, L1 is A plus B star, L2 is A power n, B power n such that n is greater than or equal to 0. Now what happens in this question is you will write L1 as regular, you will write L1 as regular and you will write L2 as context free language. You will write L2 as context free language, right? You will write L2 as context free language and then you will try to upgrade it. You will try to upgrade it to context free language. Now you will see that L1 union L2. Now you will see that L1 union L2 is equal to L1 union L2 is equal to context free language. L1 union L2 is equal to L1 union L2 is equal to context free language. Union of two context free languages is context free, right? But this is a mistake. If you directly apply the table, this is a mistake. Whenever languages are given, you can give a tighter answer. This answer is right. L1 union L2 equal to CFL. This answer is right. But then this answer is right. This answer is right actually, but then this is not tight. Why is this not tight? If L1 equal to A plus B star, if L1 equal to A plus B star and if L2 equal to a power n, b power n such that n is greater than or equal to 0. If L2 equal to a power n, b power n is greater than or equal to 0. If I take the union, if I take L1 union L2, what should we get? We are going to get a plus b star, right? And this is actually regular. This is actually regular. This is actually regular. This is actually regular, right? So this is how you can answer the questions from this table. Okay, so you know everything about this table, but there is something that you might not be knowing about this table, that is homomorphism and inverse homomorphism. Inverse homomorphism is not in syllabus, you don't have to read about it, but homomorphism is there in syllabus, you have to read about it. Now homomorphism, what is homomorphism? Homomorphism means substitution. Okay, homomorphism means substitution. Homomorphism, homomorphism means substitution. Homomorphism means substitution. Homomorphism means substitution, right? So what do I mean by substitution? What is homomorphism? Okay, let us say there is a language. The language is 0111110, right? And homomorphism of 0 is, let us say, A, and homomorphism of 1 is, let us say, BB. Then what is the homomorphism of the language? What is the homomorphism of the language? In place of 0, you are going to put a, and in place of 1, you are going to put BB. And in place of 1, we are going to put BB, BB. And in place of 1, we are going to put BB, BB. And in place of 0, we are going to put a. This is called homomorphism of the language. Inverse homomorphism is not there, okay, in the syllabus. You don't have to worry about them. And what other questions then can they ask? They can ask some questions like this. It is just a 2 hours lecture, you will get 4 marks. Just be patient and go through all the tables. You will definitely get 4 marks. It is just a 2 hours lecture, okay? So what other questions they can ask is, some type of questions which is asked in GATE is, which of the following languages are not closed under union, right? Which of the following languages are not closed in, which of the following languages are not closed in, what is the question given in GATE? Is not closed in union. Is not closed in union. So options given are like this: A, regular, B, DCFL, C, CFL, D, CSL. I'll give you poll, you answer it. Oh, there is no poll option in white YouTube, right? Sorry, there is no poll option in YouTube. There is no poll option in YouTube. Okay, so what I will do is, so सर ర్యాప్ हो जाए, ठीक है, పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పెట్టుకున్నవన్నీ నువ్వు కట్టుకపోతావారా, పోరి పోరి అంటావు దాన్ని చుట్టుకుంటావారా, సక్కపోసి పెగ్గేస్తా ఆ ఆ ఆ ఆ, ठीक है? अभी तो पार्टी शुरू हुई है and we have completed one table. इसमें से one question, you are going to get one question from this table which is very easy to answer. What is the question? Which of the following languages are not closed? मतलब what they have given? Regular, DCFL, CFL and CSL. So which languages are not closed? DCFL is not closed. DCFL is not closed, right? DCFL is not closed, and you can answer any question like that easily. So one table is over, right? Right. So I will give you one difficult question, try to solve it. I will give you one difficult question, try to solve it. We will take the same table. This question is not asked in GATE. I created the question so that there will be some difficult questions. Actually, I take GATE questions and I extend them and I make them more difficult so that you will find it easy in the exam. Okay. Okay. So that you will find it easy in the exam. Okay. So what about this? Regular union DCFL reversal intersection CFL, right? You should know what is the precedence first. So reversal will have highest precedence. After reversal, intersection will have highest precedence. And after intersection, union will have highest precedence. Right? So regular union reversal of DCFL intersection CFL is given. First you try to find out the reversal. What is reversal of DCFL? Reversal of DCFL is not closed. So we cannot do it at this level. Go to the next level. Every DCFL is CFL. Therefore you upgrade it. So what I will do is I will upgrade it. Regular union. I will write DCFL is not closed under reversal, right? DCFL is not closed under reversal, so we will go to CFL, right? So we will go to CFL reversal intersection CFL. Now what is the reversal of CFL? Reversal of CFL is CFL. So what is this? Regular union CFL intersection CFL, right? Now what about intersection of two CFLs? If you observe it, intersection of two CFLs are not closed, therefore I have to upgrade them to CSL. So I am going to upgrade these two into CSL because they are not closed, right? So what do you get? Regular union CSL intersection CSL. Okay. Now what is CSL intersection CSL? It is CSL. So what do I get? Regular union CSL. Now regular and CSL cannot be compared. So I am going to upgrade regular to CSL. What do I get? CSL union CSL. CSL union CSL is CSL. So the answer is CSL. Later I will give you a small table using which you will be able to answer it very easily. Okay? Hello sir, how are you today? Feeling good? Yes, I am good. Yes, I am feeling good. Don't try to answer immediately. Take some time, think about it, and then answer. You have directly answered it as DCFL. How is it DCFL? It has to be CSL, right? It has to be CSL. Don't try to answer the question immediately. See, one thing, while preparing for GATE, you have to take lot of time, but in the exam you have to take less time. Okay? While preparing for GATE, you have to take lot of time. Okay? 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 See, I will tell you one thing. Hope is the best thing in life. Many of you are not able to answer the questions, therefore you are giving up. I will tell you a small story. Okay, let us say you are lost in a jungle. You are in a jungle and you went for camping and somehow you got lost. Now you are in jungle for 3 days. You don't have food, you don't have water, you don't have sleep, and you are lying down, you are not able to get up from that place. And suddenly, all of a sudden, in the midnight of the fourth day, you are able to see a small light at a very far distance. That will give you hope. Now, the hope is that there may be a home there may be people there who will give you food, water, and bed. That hope will make you get up, will make you dust down, and will make you run towards the hope, towards the fire. In life also, you should always have hope. If you have hope, you will not give up. You will keep trying, you will keep walking, you will keep flying, you will keep running towards your goal. Okay? hope is the most important thing. Have the hope that you may get a seat in IIT. With that hope, you will definitely be able to get into IITs. Are you understanding what I am saying? You are in a jungle and you have no food for 3 days, no sleep for 3 days, and you don't have bed for 3 days, and you are continuously walking in search of a road. You didn't find it, but at a far distance you are able to see a small light. That light might be a firefly also. That light might be a firefly also. That light need not be a home also. But still you will have the hope that, oh, that could be a home which could give me food, which could give me shelter, and I can be alive, right? And with that small hope, you will definitely run towards that light. Now that light is AIR1. Have that hope that you are going to get into AIR100. Have that hope. That hope will make you work hard. Every step you take, that should take you closer to your goal. Okay? Okay? Fine. Fine. So this is all about table 1. Anyway, table 1 is easy. So now let us see one more in relation with the table. Let us see something. Okay? Let us see something in relationship to the table. Okay? In relationship to the table, let us see something. Precedence order is same. Precedence order mein na, there are nothing much. Reversal is greater than, concatenation is greater than union. Union comes last, concatenation comes first. Okay? And if there is complementation, they will give you brackets. Generally what they do is, if there is a complementation and a reversal, they will give you like this. Initially complementation is applied and then reversal is applied. Complementation is applied and then reversal is applied. Okay? Complementation is applied and reversal is applied. Okay? So now I will tell you some of the important points which are related to table only, but then I am not able to put them in table because they fall in a different category. Okay? So no language is closed under following operations. No language is closed. No language is closed under following operations. No language is closed under following operation. No language is closed under following operation. We have subset operation, we have superset operation, we have infinite union, we have infinite union, and we have infinite intersection, infinite intersection, and we have infinite set difference, infinite set difference, infinite set difference, okay, which is minus, infinite set difference which is minus, infinite set difference which is minus. ठीक है, infinite set difference which is minus. Okay, union, subset, superset, infinite union, infinite close, and infinite set difference. We have to see all of this. Okay, so what this rule is saying is, no language is closed under these operations, right? I will prove for regular and then you prove for other languages. Proofs are not required. If you remember this, that is sufficient. Proofs are actually not required, but I will give you a proof. Okay, I'll give you a proof, right? So let L1 equal to A star B star and L2 equal to A power n B power n. Now we can clearly say that L2 is a subset of L1, which means A power n B power n is a subset of A star B star. A power n B power n is a subset of A star B star. A power n B power n is a subset of A star B star. Okay, A power n B power n is a subset of A star B star. A power n B power n is a subset of A star B star. What do you mean by that? The subset of a regular language need not be regular. What is this language? This is regular. If I take the subset is may or may not be regular. The subset is not regular, but I can show you one thing. Phi is a subset of A star B star, right? Empty set is a subset of any set. Now A star B star is regular. A star B star is regular and phi is regular, which means if I apply subset operation, the resulting language may or may not be regular. If I apply subset operation, the resulting language may or may not be regular. The resulting language may or may not be regular. Similarly, you can prove the other things also, right? If I take superset, what example should I take for superset? I will take phi and A power n, B power n, okay? So, phi has a superset A power n, B power n such that n is greater than or equal to 0. What is phi? Phi is regular. Hana. And what is A power n, B power n? A power n, B power n is non-regular. Non-regular, right? So, superset of a regular language can be superset. Superset of a regular language. The superset of a regular language can be non-regular. And superset of a regular language can be regular also. So, if I write like this, phi is actually, here I have to write subset. Phi is subset, right? So, phi superset is A power n, B power n is superset of phi, right? So, this is non-regular and this is regular, right? This is regular, right? So, you can prove all the points like this. Sir, you are my hero and idol both. I am working hard to make you proud one day. Don't work hard to make me proud. You have to make your parents proud. Sir, you have not taken the difference closure property. Closure properties are sufficient. Whatever I told you is sufficient. Sir, how do we know the precedence order? I told you. Sir, what happens if infinite intersection is there? I will tell you. Infinite intersection and infinite union, I will tell you now. Okay. Now let us say AB is a language. AB is a language. I will write all the languages. AB is a language which is regular. Union AABB is a language which is regular. Union AAABBB is a language which is regular. Union AAAAABBBB is a language which is regular, right? Now if I go with infinite regular, then what happens is, that the language that we get will be A power n, B power n such that n is greater than or equal to 0. So, union of these many regular languages is not regular, right? So, A power n, B power n is not regular. It can be regular in some cases also. In some cases, it can be regular. For example, if I write A, if I take union of all this, union so on. Now this one is regular. A is regular. A is regular. A is regular. This one is regular. This one is regular. Right? All of these are regular. A, all these are regular, right? Now, what is this language? A power n such that n is greater than or equal to 1. Therefore, this is regular. What do I mean by it? Sometimes it may be in infinite union of regular languages. Sometimes it can be regular. Sometimes it can be non-regular. Right? What, sir, you didn't mention the set difference property in RBR table 1. So 1 minute, I have a small table here. I will give you set difference in a different table. Okay, I have the next table. Actually, set difference can be derived from intersection. Just hold on. This is a very genuine doubt you have asked. Pranav Bople, you have asked a very good doubt. You have asked a very good doubt, right? I will answer your doubt, okay? But then give me some time, okay? Give me some time, okay? Let's take a small break and get back, okay? I will take the next table. Let's take a small break and I will get back, okay? Just take 5 minutes break. We will get back and continue, okay? Abhi, just now we have proved that infinite union may or may not be closed, right? So the following properties, what can you derive from this? Infinite union of regular languages may or may not be regular is what you have to learn from this, right? Right? Now we will do infinite intersection. Infinite intersection. Infinite intersection. Infinite intersection. What is infinite intersection? If I have L1 intersection L2 intersection L3 intersection L4, so on. If I have L1 intersection L2 intersection L2 intersection, so on. Now I can write it as where L1 is a regular language, L2 is a regular language, L3 is a regular language, L4 is a regular language, right? Now I can write it as L1 complement union L2 complement union L3 complement union L4 complement, so on, right? Now this is whole complement, okay? This is nothing but infinite intersection. Now if a language is regular, its complement is regular. If a language is regular, its complement is regular, its complement is regular, its complement is regular, right? Right? So the languages, all these languages are regular and we are applying union to them. Just now we have learned that infinite union may or may not be closed, right? Therefore, this part, if you observe it, which is infinite union, this may or may not be regular. This may or may not be regular. Now if I take the complement of it, that will also may or may not be regular. That will also may or may not be regular. That one is also may or may not be regular. In Parakram batch, RBR sir will teach TOC from 28th July. Acha, from 20th July there is my class, is it? सर आज आपके ये लेक्चर चंदन सर भी अपने हर एक GFG टेलीग्राम ग्रुप में शेयर किए था. It shows that other faculties respect quality content over competition. कौन? Who is this guy? चंदन सर? मुझे पता नहीं चंदन सर कौन है, और वो GFG का टेलीग्राम ग्रुप में मेरा लेक्चर शेयर किया है. चंदन सर, I want to really thank Chandan sir. If you have Chandan sir's number, can you please post it? If someone has Chandan sir's number, I want to thank him. Actually, we are competing in GATE, right, with other institutes, but a faculty from a different institute sharing my lecture in their official channel is a great thing. If someone has Chandan sir's number, please share with me. I want to thank him. Okay, I want to thank him. Okay, it may or may not be regular. We got it. So infinite intersection may or may not be regular. What about infinite set difference? What about infinite set difference? Infinite set difference. Infinite set difference means L1 minus L2 minus L3, so on. That equal to L1 intersection L2 complement intersection L3 complement intersection L4 complement, so on. Right. So we have already seen that L1, L2, L3 all are regular. This is regular, this is regular, this is regular, and L1 is regular, L2 complement is regular, this is regular, this is regular, this is regular, and this is regular, right? Just now we have seen that infinite intersection is may or may not be regular, isn't it? So this language, which is in infinite intersection of regular languages, this may or may not be regular. May or may not be regular. May or may not be regular, right? So we have covered one table. Now we have to see secondary operations. Small topic is Chandan sir is a DSA teacher. Acha. I don't know when this batch is starting. If you are sure that it is starting from 28th, I think I will be mostly taking the class. Okay. Let me see when the classes are. Okay. 6 months is enough to get into top IITs. Pranav, 6 months is enough to get into top IITs. If you dedicatedly spend 8 hours per day, if you are able to spend 6 hours, 6 months is definitely sufficient. 6 months is definitely sufficient. Okay. So, secondary operations. Secondary operations. Some people were asking about set difference, right? Secondary operations will get set difference. Now, if I have L1 minus L2, L1 minus L2, then what will it be? L1 intersection L2 complement. Okay. If I have L1 exclusive or L2, what will it be? L1 intersection L2 complement union L1 complement intersection L2. L1 complement intersection L2. If I write L1 implies L2, if I write L1 implies L2, then it will be L1 complement union L2. L1 complement union L2, right? If I write L1 L2 by implication, if I write L1 L2 by implication, then it is going to be L1 intersection L2 L1 intersection L2 union L1 intersection L2 complement, which means even though these operations are not in the table, you can derive them and you can apply the table. Okay. And L1 NAND L2 is equal to L1 intersection L2 whole complement, and L1 NOR L2 is equal to L1 in union L2 complement. L1 union L2 complement, right? So now what you should be doing is, whenever secondary operations are given, don't directly try to convert them into, don't directly try to upgrade them. I'll give you an example where you may do something wrong here. Okay. So let us take this table. I will show you one example here. Where you may do something wrong. Okay. So if you follow the first table, you may do something wrong. What mistake that you may make is, if I write RE minus REC, if I write RE minus REC, now according to this table, you will upgrade REC to RE, right? You will upgrade REC to RE. Now what does that mean? RE minus RE. RE minus RE. RE minus RE, right? Now you will try to complement it. You will try to write it as RE intersection RE complement. You will try to complement it. RE intersection RE complement. You will try to complement it. Now what is the problem here? The problem is RE complement. If you look at RE complement, it is not closed, which means this is may or may not be RE. May or may not be RE. Therefore, you might make a mistake. That is why don't directly upgrade the language in the secondary operations. First, you try to convert the secondary operations to primary operation, right? So what do I mean by this is, first you convert secondary operation to primary operation. For example, if you have RE minus REC, first you convert it. What is RE minus REC? RE minus REC is RE intersection REC complement. RE intersection REC complement. Now you know REC complement is REC, right? Here in the table you can see that REC complementation is REC, right? So what do you get here? REC complement is REC. So you are going to get RE intersection REC, right? Now you can upgrade RE. Now you can write RE intersection RE, and RE intersection RE is closed, therefore the answer will be RE. So what I mean to say is, whenever you are applying the secondary operations, don't directly upgrade the language. Don't directly upgrade the language, okay? My suggestion is, whenever you are applying the secondary language, secondary operators, don't directly convert them to or upgrade them to the next level. First you expand it, then you apply the table, then you will get the answer, right? So this is about the first table. This is about the first table. Now we will see second table of RBR. Sir, you literally teach better in English than Hindi. Every concept gets easier. My Hindi is also good. My Hindi is also good. My Hindi is also good. Sorry for disturbing in between classes. Sir, how can I get one-on-one mentorship from you? Akash, I don't have a lot of time to do one-on-one mentorship, but I had to talk to the management once about one-on-one mentorship. ठीक है? I will just note it down so that I can ask the management for one-on-one mentorship. Okay. I will ask the management. Okay. I will ask the management about this. Please give me some time. How to do one-on-one mentorship with my limited amount of time is something that I need to discuss. Okay. I will definitely discuss it with the management. And if management says that I can do one-on-one mentorship, then I will definitely be able to take that. Okay. I will definitely be able to take that. Okay. Okay. Okay, fine. So this is about the first table, table number 1. Now let us see RBR table number 2. RBR table number 2. What does RBR table number 2 says is, table number 2 says is, if we have a language and if you union with a regular language, the resulting, if you have a language and if you union with regular language, it is regular DCFL, CFL, CSL, REC, and RE and RE. Now what do I mean by this is, if I take any language and if I apply union with the R, regular language, then you get the same language, which means all of them are tick, right? What is the meaning of this tick? This tick says that if there is a DCFL language, if I apply union with a regular language, the resulting language will be DCFL. That is what this table says. You can apply it for intersection also. L intersection R. Also all are ticks. L intersection R are also all are ticks. Right? Now what about L minus R? It is also all are ticks. Right? This is RBR2. Let us solve some questions on this table so that you will get some practice. But when you teach in English, it is much easier to understand. Shantanu, my Hindi is not that good, but what can I do? There are North Indian students who are not comfortable, right? Sir, revision करके मजा आ रहा है. You and Goti sir are my heroes. Goti sir is a very good faculty for CO and operating systems. Goti sir is my junior at IASC. So I am very glad that you are liking teachers from IASC than IIT Bombay. Okay. Actually, there is a conflict that always goes between IASC and IIT Bombay, right? ओके, DBMS का कोर्स लेकर आएगा या आफ्टर TOC is over, I will bring DBMS to YouTube. Okay, what is the weightage of compiler design in actual gate question? Weightage of compiler design will be around 6 to 8 marks. 6 to 8 marks. Okay, yes sir, I followed you in LinkedIn, if you may remember. Akash Tiwari, you followed me on LinkedIn, is it? I didn't actually, I don't remember you, but I will see it. East or West, RBR sir is best. Thank you so much, guys. Thank you so much. You know the beauty of 12 o'clock? Do you know the beauty of 12 a.m.? Can anyone say what is the beauty of 12 a.m.? Can anyone say what is the beauty of 12 a.m.? Can anyone say what is the beauty of 12 a.m.? At 12 a.m., one day will end and the second day will start, which means you are ending a day with me and starting a day with me. Okay? You are ending a day with me and starting a day with me. That is the meaning of it. Okay? Okay? We know the reason why the sir god of CS. Day end with RBR and day start with RBR. Silent mode. We can end the day with you and start the day with you. That is the beauty of 12 a.m. Right? Next day starts. Oh, already date has changed. Now it is 26th. We started the class on 25th July and we are continuing it on 26th of July. Okay. I will take your comments. Sir, you are my idol. I will take your comments. Let me finish this concept. Okay. I will take your comments. Okay. Now let us say there is a language given like this. Regular minus DCFL is given. What is the language? Regular minus DCFL is given. What is the language? What can you write? You can write this language as regular intersection. You have to expand it. DCFL whole complement. And DCFL whole complement is DCFL. Regular intersection DCFL. Right? Now regular intersection DCFL. Here I told you that a language intersected with regular language is always that language. Therefore, this is DCFL. Therefore, this is DCFL. Right? 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 Now, what is DCFL minus regular? What is DCFL minus regular? Right? What is DCFL minus regular? You can directly apply this table. DCFL is L minus regular. You know that it is directly DCFL. So this is DCFL, right? Now don't go to the big table. If you can solve it using, if you can solve a question using RBR table 2, don't go to RBR table 1. You may get the answer, but that answer might not be tight. Okay? That answer might not be tight. I will show you why that might not be tight. Okay? What was the question? The question was DCFL minus regular. DCFL minus regular, है ना? The question was DCFL minus regular. I will just explain you the question, what mistake you could make here. We will make all the mistakes here only so that in gate we don't make any mistakes. Okay, just be careful when RBR 1 table is given and RBR 2 table is given. You have to apply RBR 2 first, then RBR 1. Okay, if you go with RBR 1, the answer may be loose. Okay, so what was the question? The question was DCFL minus regular, है ना? The question was DCFL minus regular. The question was DCFL minus regular. Now if you try to apply this table, you will expand it like this. You will expand it as DCFL intersection regular complement. Now we know that complement of a regular language is regular. So you will write like this, DCFL intersection regular. Now we cannot apply first table on these two languages, right? So what will you do? You will do like this, DCFL intersection DCFL. You will upgrade regular to DCFL, but the problem is DCFL is not closed under intersection. DCFL is not closed under intersection. So you upgrade them to CFL. Now you upgrade them, both of them, to CFL. CFL intersection CFL. CFL intersection CFL. Now again you will find that both of them are not right. CFL intersection CFL. Again you will find that both of them are CFL intersection CFL. Again you will find that both CFL intersection CFL are not closed. Therefore what you will do is you will go to CSL. You will upgrade both of them to CSL. CSL intersection CSL, right? Now what do you get CSL under CSL? It is CSL. Now you will say the answer is CSL. If you use RBR table 1 directly, you will get an answer which is also right but not tight. But if you do RBR 2 table, if you see RBR 2 table, it is giving you a tight answer. What is the answer it is giving? It is giving the answer is DCFL. This is a tight answer, that was a loose answer. So always apply RBR table 2 before you apply RBR table 1. Okay? Okay? Before you apply RBR table 1, sir, you are my idol. When TOC is going to over? I think TOC is going to over. Why are you in fear when RBR is here? Sir, is it like more priority given to RBR table 2? Yes, yes, Pranav. More priority should be given to RBR table 2. If RBR table 2 can't give you the answer, then go to RBR table 1. Okay? Remember that. Okay? Now let's solve some more questions here. DCFL minus regular is over. Now what if I say regular minus CFL? What if I say regular minus CFL? Regular minus CFL, right? So this can be written as regular intersection CFL complement, but CFL complement is not closed, right? Therefore you will upgrade it to CSL. You will upgrade it to CSL, regular intersection CSL. Now apply table number 2. Intersection says that if any language is intersected with regular language, the answer will be the same language. Therefore the answer is CSL. Therefore the answer is CSL, right? Right? So what did I do? I have, this is a secondary operation which I expanded. After expanding the secondary language, I got this language, right? 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 So first I have taken the CFL complement which is not closed. So I upgraded to CSL. So I got CSL. Now CSL intersection regular is CSL. CSL intersection regular is CSL. Okay? Sir, please do compile and design before DBMS. I think that makes sense actually, Ram. If I do compile and design before DBMS, that makes sense. Okay, I will try to do compile and design before I do this DBMS. Okay, next subject on YouTube channel will be compiler design. I will discuss this with Vishwadeep Gothi sir. Vishwadeep Gothi sir is the head of academics for GATE Computer Science. I will discuss it with him and I will get back to you. Okay, let me ask sir, or even if you are in, if you have direct contact with Vishwadeep sir, you can just ask him what you want. He will try to arrange it. Okay. The problem is I have limited amount of time and there are a lot of subjects and batches. That is why I'm not able to teach all the subjects. But then if I get time, I will definitely do compiler design. I will definitely do DBMS. Okay. 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 So let's finish this. Let's finish this table and then we will talk. Okay. Now regular minus CFL is done. Now CFL intersection regular. Now CFL intersection regular. First apply table number 2. Regular language is intersected with CSL, we get CSL. Regular language is intersected with CSL, we get CSL. Sorry, CFL. Here it is CFL, right? Regular language intersected with CFL is CFL. So you can directly write it as CFL, right? But the problem is if you use table 1, you will get a wrong answer. You will get an answer but which is not tight. If you use table number 1, what it will say, it will ask you to upgrade regular to CFL, regular to CFL. Now if you see CFL and CFL, here if you see CFL and CFL, intersection is not closed, right? Intersection is not closed. Here intersection is not closed, so you will upgrade them to CSL. You will upgrade them to CSL, intersection CSL, and the answer you will get is CSL, right? So this is also right. This answer is also right but not tight. What is the tight answer? CFL is the tight answer, but the table 1 gives you loose answer. So always apply table 2 before you go to table 1. Always you go to table, always you apply table 2 before you go to table 1. Okay. Okay. Now let us take one more question, last question, and then we are completing 2 tables. Okay. Today I will complete all the 4 tables. Okay. So let us do one more example. One more question. The next question is regular minus REC. The next question is regular minus REC. How can you write it? You can write it as regular intersection REC complement. Regular intersection REC complement. Regular intersection REC complement. Right? 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 So regular intersection REC complement we are going to write. And what is REC complement? REC complement is REC. Now what did we get? We are now getting REC intersection regular. REC intersection regular, right? We are now getting REC intersection regular. Now REC intersection regular is REC. Therefore the answer is REC. You have to use both the tables. You have to use both the tables. Okay. What is the weightage of digital logic in GATE exam? Yeah, 4 to 6, 6 to 8, something like that. 4 to 8, 6 to 8, something like that. Okay. Okay. REC. So we have completed all the examples. Now we are going to go to the next table. So I told you that I will finish 4 tables. Now I have finished 2 tables. After this, I will finish the next 2 tables. Let's take a small break and then we will finish the remaining 2 tables. Okay. Let's take a small break. Sir, what if it is asked in the form of MSQs? Which one would be right? Always tight one should be right. They will not ask such questions. Okay, they will not ask such questions in MSQs. They will only ask tight questions. Okay, let's take break for 2 minutes and then I will start with table number 2. Okay, table number 2. Now we will see RBR table number 3. Okay. Now we will see RBR table number 3. RBR table number 3. Okay. So in this table, most of the things are useless. So I'll read your comments. Okay. Shantanu, it's leaderboard. Click on crown icon. You will get it. Leaderboard. Click on crown icon. You will know it. I don't know why some people are getting crowns. Number 1. Lydia is at number 1. Prashant is at number 2. I don't know who is number 3, but I don't know how you are getting those. Sir, yesterday after the class, I saw your life story on YouTube. It is truly inspiring and it shows enormous possibility of life. I also showed clip of video to my mother. She said, learn from him. Okay. So actually, my life story will be posted on Physics Wallah channel also, so that it will reach many people. I will talk to the management and I will see that my life story is on Physics Wallah channel. Okay. So now RBR 3. Now RBR 3. So it is only for regular and context free. Prefix or init. Suffix. Right quotient. Right quotient, left quotient, right quotient, left quotient, right. So this table is only for regular and CFL. Regular and CFL. In suffix and prefix, both regular and CFL are closed. Suffix and prefix, both of them are closed. In right quotient and left quotient, both are closed. Both are closed. That's it. It is very easy to remember. It is very easy to remember, right? Prefix, init, postfix, right quotient, left quotient. But you don't know what is prefix, what is init, what is suffix. You don't know all this. I will explain you all of them one by one. Okay. First, let's go with init of L. First, let's go with init of L or prefix of L. Init of L or prefix of L. Init of L or prefix of L, right? So L equal to 10 followed by 001. 10 followed by 001. Okay, what is prefix of L? What is prefix of L? Prefix of L equal to whatever you get here, prefixes. Epsilon, okay, I will take step by step. If I take 10, what is prefix of 10? What is prefix of 10? Epsilon will always be a prefix, 1 will be a prefix, 10 will be a prefix. If I take 001, what will be prefixes? Epsilon will be a prefix, 0 will be a prefix, 00 will be a prefix, 001 will be a prefix, 001 will be a prefix. Okay. Okay. So always remember one thing, epsilon always belongs to prefix of a language. Epsilon always belongs to prefix of a language. Epsilon will always belong to prefix of a language. What is the only exception? Except when L is not equal to 5. Except when L is except when L is not equal to 5. Whenever L is not equal to 5, epsilon always belong to the prefix of the language. Epsilon always belong to the prefix of the language. Right, right, right. And second point is L is always a subset of prefix of L. L is always a subset of prefix of L, right? Now L is 10001, right? L is 10001, right? L is 10 followed by 001, right? L is 10 followed by 001, isn't it? L is 10 followed by 001. L is 10 followed by 001. Now this language will also be present in prefix of L. If I write prefix of L, what did I get? If I write, let us say L equal to this. If I write prefix of L, what did I get? I got epsilon, I got 1, and I got 10, and I got epsilon, and I got 0, and I got 00, and I got 001, and I got 001, and I got 001. So 10 is present as well as 001 is present, which means a prefix of L will always contain L. Remember these two rules. Epsilon always belongs to prefix of a language, and also a language is a subset of prefix of a language. Okay. Now I'll ask you some interesting question. You answer me. Okay. I will ask you some interesting questions. You answer me. Okay. So if L is finite, if L is finite, if L is finite, then prefix of L is finite. Then prefix of L is, if L is finite, then prefix of L is finite, right? Right? If L is infinite, if L is infinite, then prefix of L is infinite. Prefix of L is infinite. If L is infinite, prefix of L is infinite. Prefix of L is infinite. Okay, sing one song. Song over. I think already. Unstoppable Indian slide. Okay, let's do a story once. Okay, let's see Unstoppable Indians. So, whom do you want to talk about? Sania Mirza. Sania Mirza was born in 1986. She is 2 years younger to me, and she became India's first female tennis player to rank number 1 in doubles. She was ranked number 1 in doubles, winning 6 Grand Slam titles. Despite injuries and societal expectations, she returned to win the Australian Open mixed doubles in 2015. Mirza uses her platform to advocate for women's empowerment and break stereotypes in sports. What is the lesson you should learn from Sania Mirza? Breaking barriers requires self-belief and using your voice to empower others. Right? That is what you can learn from Sania Mirza. Sania Mirza is an Indian, even though she is in Pakistan. So we should feel proud that Sania Mirza is from India. Jai Hind, Jai Hind, Jai Hind. We have heroes. India has lot of heroes, and I will remind you who all those heroes are. Okay, Jai Hind. Now let us see. Now let us see. I will give you a question. You tell me the answer. Okay. I will give you a question. You tell me the answer. L equal to A star. L equal to A star. Then what is prefix of L? What is prefix or init of L? What is prefix or init of L? L equal to A star. What is prefix or init of L? What is prefix or init of L? What is prefix or init of L? Very good, Pranav. Sir, how do you manage work-life balance? I will tell you one thing. There is nothing called work-life balance. If you love your work, there need not be any balance. If you love what you are doing, you will never ask for work-life balance. If you don't love what you are doing, then only you will ask for work-life balance. I love teaching. Teaching is my passion. Even if they don't pay money also, I will still be willing to teach. Right? So there is nothing called work-life balance. Forget about it. There is only work in life. There is no life. There is only work in life. When I teach, I forget the world. Right? Therefore, there is nothing called work-life balance. This is invented just to fool you. There is only work in life which you love. Keep doing what you love. That is what is just my philosophy. Keep doing what you love. Okay? Okay? Okay. L equal to A star. What is prefix of L? Very good. So many people have answered it. Prefix of L is A. So you can write the language, right? L equal to epsilon, L equal to A, L is A, L is A, L is A, so on, right? L is A, so on. L is A, so on, right? What is prefix of epsilon? Prefix of epsilon is epsilon. What is prefix of A? Prefix of A is epsilon comma A. What is prefix of A? Prefix of A is epsilon A is the prefix, right? So if you keep writing this, you are going to get epsilon, you are going to get A, you are going to get A, you are going to get A, so on. 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 Okay? You are going to get A, so on. So what is it? A star. What is it? A star, right? Now I'll give you one more question. Find out prefix. If L equal to A plus, what is the prefix or init of L? If L equal to A plus, what is the prefix or init of L? The subject with highest weightage in GATE exam is engineering mathematics, and after that computer networks. So I teach computer networks. If you join my computer networks course, I will teach it for 150 hours. Computer networks course will go for 150 hours. Okay, that is the subject which is having highest weightage. If L equal to A plus, what is prefix or init of L? Very good. Many people have answered it. It is A star, right? Why? If I write L, what do I get? I get A, I get A, I get A, I get A, so on, right? Now, what is prefix of epsilon? A. Prefix of A is epsilon. Prefix of A is epsilon A, and then prefix of A is epsilon A, so on. Epsilon A, so on. Right? Right? Now, if I write the language, what do I get? I get epsilon A, so on. Epsilon A, so on. So on. Epsilon A, so on. So what is this? A star. What is this? A star. Now I will give you one question. If anyone is able to answer this, they will get a rank within 100. Okay. I will give you one question. If anyone is able to answer it, they will get a rank within 100. If anyone is able to answer this question, they will get a rank within 100. They will get a rank within 100. Average song. You want a song? Okay, let me sing a song. తెలవారితే కనురెప్పల తొలి మెలకువ నువ్వే నా గుప్పెడు గుండెల్లో చిరు చప్పుడు నువ్వే పొలమారితే నీ మనసుకి అది నా పొరబాటే నీ పేరే పలకడమే పెదవుల కలవాటే వెన్నెలలా ఉంటుందే నీ పక్కన చోటే వేకువలా చూస్తోందే నువ్వు నడిచిన బాటే ప్రాణాలే తీస్తోందే నీ ఊహలతోటే నా మనసే నీదాయే వినదే నా మాటే. Okay, song is enough. And computer networks playlist in physics Wallah is not sufficient. If you want to learn real computer networks, you have to take the subscription. Okay, so I will give you one question. I will give you 5 minutes. If you are able to answer it, you will get into top 100. You will get into top 100. Okay, so let the question is a equal to ab star. A equal to ab star. Now I want to find prefix or init of L. I want to find prefix or init of L. If anyone is able to answer this, you will get in top 100. I am looking at your comments. I am looking at your comments. If anyone answers it right, I will explain it. Okay. If anyone, I am giving you 5 minutes of time. In this 5 minutes, if you are able to answer this, you will get into top 100 definitely for sure. Okay. You will get into top 100 definitely for sure. No one is able to solve it. It is very difficult question. You will not be able to solve it without me explaining it. Okay. If I explain it, you will easily be able to solve it. If I don't explain, you are not going to solve it. Okay. So what is the language? Language is AB star. What is AB star? One thing you have to understand is AB star, AB star is not equal to A star B star. These two are different. Okay. AB star is not equal to A star B star. These two are totally different. Okay. AB star is not equal to A star B star. These two are not totally different, and it is also not equal to A plus B whole star. Right. Now let's take the language L. L is AB star, right? So what do you get in L? You will get epsilon, you will get AB, you will get ABB, ABAB, you will get ABAB, and you will get AB, 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 so on, right? So on, so on. Now I will take this AB, AB, AB. I will take this AB, AB, AB. I will take AB, AB, AB. Right? Now I want to find out the prefix of this. I will find out the prefix of this. What will be prefix? Epsilon will be a prefix. Epsilon will be a prefix. A will be a prefix. AB will be a prefix. AB will be a prefix. And then AB followed by A is a prefix. And then AB is a prefix. AB is a prefix. And then AB A is a prefix. And then AB is a prefix. AB is a prefix. AB is a prefix. Right. Epsilon is a prefix, A is a prefix, AB is a prefix, ABA is a prefix, ABAB is a prefix. Okay. Now see what are the building blocks. How are these strings formed? You can observe one thing, that we are building everything using only two things. One is AB and then A. One is AB and then A, right? So definitely AB star is there. I told you that L is a subset of prefix of L. L is a subset of prefix of L. है ना? L is a subset of prefix of L. Therefore, L is a subset of prefix of L. L is a subset of prefix of L, right? Therefore, what do we get here is, AB, you will get AB star, so that this string will be generated and this string will be generated. Otherwise, what you get is AB star followed by a, because AB followed by a. Otherwise, you will simply get a, and if I put a 0 here, I am getting a also. And epsilon is there in the language, and AB star is covering a epsilon. AB star has epsilon, so I can directly put like this. So this is the prefix of the language. You take a string, find out all the prefixes, and then you can analyze how you can generate all those prefixes, right? So AB star is a prefix, AB star followed by A is a prefix. AB star is a prefix, AB star followed by A is a prefix. AB star is a prefix, AB star followed by A is a prefix. Right. Now if I pull out AB as common, AB star as common, then what do I get? I get epsilon plus A. If I get AB star, if I pull out AB star, then I'm going to get epsilon plus A. Epsilon plus A. epsilon plus a. Okay. Okay. This is about this question. Now let's do one more question. L equal to a star b star. What is init of L? What is init or prefix of L? What is init or prefix of L? L equal to a star b star. What is init or prefix of L? What is the meaning of ambiguity in simple language in TOC? Ambiguity means if for a, in simple words, if I have to tell you, if there is a string, if there is a grammar, and if there is a string, and if I am able to generate more than one parse tree, for this string, then it is ambiguous. Then it is ambiguous. Then it is ambiguous. Okay. It's easy. A star, B star. 6𝐶𝐬𝐬. Your answer is right. It is A star, B star, right? If you write, see, one more thing that you understand here is whenever A star, B star is given, this is not equal to AB star, or this is not equal to A plus B star. Okay? This is not equal to AB star, this is not equal to A plus B star. But then if you look at A star, B star, you will get A star here and you will get B star here. If you get A star, B star, you will get A star here and you will get B star, which means A star is a subset of A star, B star, and B star is a subset of A star, B star. B star is a subset of A star, B star. B star is a subset of A star, B star. B star is a subset of A star, B star, right? Now if I try to write the strings of the language, epsilon will be there, A will be there, AA will be there, AAA will be there, so on, and epsilon will be there, B will be there, BB will be there, BBB will be there, so on. Now if I start taking prefixes, I will get everything. If I start taking prefixes of all this, I will get A star. If I start taking prefixes of all thing, I will take all, I'll get all B star. And also there will be strings like this, AB, AAB, ABB, right? So if I take the prefix of all this, I'm going to get A star, B star only, right? You take any string in A star, B star, that will be prefix of some string here, right? For example, if you want to say, sir, is AABBB is a prefix in this. If you ask me if AABBB is a prefix in this language, yes, AABBB is a prefix in this language. How can I say that? Because AABBB is already in A star, B star, and it is prefix of A star, B star. For example, here in this language, AABBB is already there, right? Right. But what you will not get is BA. You will never get a BA. Why? Because whatever string you see, always A's are there followed by a B. There is no BA. There is no BA. There is no BA. There is no BA. Right? There is no BA. Now tell me about this. L equal to A plus B star. L equal to A plus B star. What is init of L? What is init of L? L equal to A plus B whole star. What is init of L? What is init of L? If L equal to A plus B star, what is init of L? answer this question. If you answer this question, I'll give you even more difficult question. Okay. I told you that L is a subset of init of L. L is a subset of init of L. Now, A plus B star is a universal language which is a subset of some language. Then this language contains everything. Therefore, this language will become A plus B star. It is a simple logic. I told you that L is a subset of init of L. L is a subset of init of L. L is a subset of init of L. I told you that. Right? Right? I already told you that L is a subset of init of L. Then A plus B star is subset of L. 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 Now, if A plus B star is subset of a language, then that language will also become A plus B star because A plus B star is universal language. You have every string in this. Now, you are saying that that is a subset of L. Therefore, what will L be? L will also be A plus B star. That is how it is. That is how it is. All of you have written it wrong. All of you have written it wrong. Right? Okay? Okay? Let me give you one more question. L equal to A power n, B power n such that n is greater than or equal to 1. Then what is init of L? What is init of L? What is init of L? If L equal to A power n, B power n such that n is greater than or equal to 1, what is init of L? What is init of L? A power n, B power n such that n is greater than or equal to 1. What is init of L? What is init of L? Yes, Satyam Raja, your chart is visible. A power n, B power n is given. What is init of L? What is init of L? Take some string and do it now. How you can answer this question? You can take some string and do it. You can take some string and do it. Take a string and you will be able to do it. Let's take a string. A, B, 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 right? Now write all the prefixes. Epsilon is there, A is there, A is there, A is there, B is there, B is there, B is there, B is there. Epsilon is there, A is there, A is there, A is there, so on. Right? 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 Epsilon is there, A is there, A is there, A is there, so on. So on. Right? Now you can see that init of L is, I already told you that L is a subset of init of L. L is a subset of init of L, which means in the answer you are going to get a power n, b power n such that n is greater than or equal to 1. And epsilon is there. Therefore, you can put union epsilon. And what are the other strings that are there? There are even more strings in which number of A's are greater than number of B's, right? Observe this. Number of A's are greater than number of B's. Number of A's are greater than number of B's. Number of A's are greater than number of B's. Number of A's are greater than number of B's. Number of A's are greater than number of B's, right? Therefore, what I can write is A power m, B power n such that number of A's is greater than number of B's. Number of A's is greater than number of B's. So this is the answer. You will get the entire language and there is epsilon there in the language, so include it, and set of all strings in which number of A's are greater than number of B's. Number of A's are greater than number of B's. Right? Got it? Got it? These are all little bit difficult questions. You will not be able to answer them directly. So don't get discouraged. Okay. There is a hope that you will get a good rank in GATE. That hope should give you lot of motivation to work. Okay. All these are difficult questions. You will not be able to answer them directly. Okay. All these are difficult questions. You will not be able to answer them directly. You will not be able to answer them directly. Right? Let me give you one more beautiful question. L equal to W such that number of A's in W is equal to number of B's in W. Whoever answers it will get a first rank. Whoever answers it will get a first rank in GATE. Whoever answers this will get a first rank in GATE. I will give you 5 minutes of time. Think about it. Try to do it. Whoever answers it will get first rank in GATE. Okay. I'll give you 5 minutes of time. Okay. So I will explain this question again. Let us see the question. I will explain this question again. Let us see the question. Number of A's in W is equal to number of B's in W. W such that number of A's in W is equal to number of B's in W. A plus B star. I want A plus B star. Okay. I want A plus B star. You can get anything in A plus B star. One thing is for sure, epsilon is always there in it, right? Now, one thing that I want to tell you is number of A's in W is equal to number of B's in W is not equal to A power n, B power n. This is number of A's followed by number of B's, equal number of B's. Here you can get any combination. You get AB, you get BA, you get AABB, you get BBAA, you get ABAB, you get BABA, so on. You get BABA, so on, so on. Right, 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 right. Now, if you want A, you take prefix here. You are going to get a A. If you want B, you take a prefix here. You will get a B. If you want AA, you take a prefix here. You will get AA. If you want BB, you take a prefix here. You will get BB. If you want AB, you will take a prefix here. You will get AB. If you want a BA, you will get a prefix here. You will get BA. If I want AAA, there will be a string in this language AAABBB. If I take prefix of it, I will get AAA, right? Now if I want AAAB, I will take this prefix AAAB. So AAAB, whatever string you want in A plus B star can be generated by prefix of number of A's equal to number of B's. Prefix of number of A's equal to number of B's in W. Number of A's equal to number of B's in W, right? This is A plus B star. Very good. A plus B star. Very good. Okay. So we will end the class here. We will end the class here. Okay. We will end the class here. I think next class, when is the next class? I will just see. Your batch is 11 o'clock batch, right? 11:15 batch. Let me just see when the next class is. 9 to 11. Udaya? 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 ఒకసారి రా. When is the next class for you? I am not able to see in the schedule. వీళ్ళకి నెక్స్ట్ క్లాస్ ఎప్పుడు? ఎక్కడుంది షెడ్యూల్? సండే కూడా ఉంది కదా. ఓ, ఇది సండే ఉంది యూట్యూబ్. సాటర్డే లేదు. సండే ఉంది. లేదు లేదు, సండే ఉంది. సో వీ హ్యావ్ ఏ నెక్స్ట్ క్లాస్ ఆన్ సండే. యా, దే నో దట్, దే గాట్ ది ప్లానర్. సండే ఉంది కదా. వాట్ టైం? So we have a class on Sunday. We have a class on Sunday, right? 11 a.m. to 1 p.m.
11 p.m. to 1 a.m.
Okay. Okay. I will confirm the timings tomorrow. Okay. I will confirm the timings tomorrow. Sir, which is this toughest subject that should be lost priority to do? I mean, which subject should I finish first? There is nothing like toughest subject, Pranav. All the subjects are easy only. It is only your perception. All the subjects are easy. Okay. I will confirm the timings tomorrow. End with Telugu rap. Okay. I will end it with Telugu rap. పోత పోత పైసలన్నీ పట్టుకుపోతావారా, పెట్టుకున్నవన్నీ నువ్వు కట్టుకపోతావారా, పోరి పోరి అంటూ దాన్ని చుట్టుకుంటావారా, పెగ్గు చక్క వేసి పెగ్గేస్తా ఆ ఆ ఆ ఆ. ठीक है. So let's end the class. Jai Hind. Jai Hind. Jai Hind. Okay.